Hello, are you there? Hello, I hope you can hear me. Hello, hello.
Hello.
Yeah, hi.
Yes, I can hear you.
Okay. Um, okay, so we'll begin our course today. Uh, the idea is to start with maths. Tomorrow we'll start with physics. And in maths, we will start with trigonometry. Okay. So the sequence of topics for us will be trigonometry, then we'll do a little bit of algebra, then we'll do coordinate geometry, this is algebra 1. Not everything in algebra. Then we'll do coordinate, then after that calculus, then let's say algebra 2, and finally vectors and 3D geometry. This is the way we'll be covering the JE syllabus. Okay, don't mute yourself, otherwise I cannot hear you and I feel like I'm talking to a wall, so it will be better. Don't mute yourself so that we can talk, right?
Yes, sir. Yes.
uh, so this is the sequence. Okay, and our goal is basically JE 2023 is the target, and we plan to finish the syllabus for JE by say June 2022. Okay, so June 2022 is our deadline to finish the syllabus. So that is finishing the syllabus in almost 15-16 months, right?
Yes.
So that might be a little challenging, but if you follow the right approach and are willing to work it out, we will be achieving this. If you can achieve this, then what will happen is they will have plenty of time after that. Exam will be in Jan and May, April. That will be JEE mains, and May 2023 will be advanced. So there will be plenty of time to revise, practice, do tests, right? To get
Yes.
better. So if this deadline gets delayed and this becomes October, November, right? Then it is ruined. You understand? If this becomes October of 2022, then it is pointless, right? Like then not enough time to practice and get better.
Yes, sir.
Because anyway, the syllabus covers the whole 2 years worth of syllabus. So it's not like you have to only focus on 12th part or something. Everything that you do from this moment on will be important. Okay. We have already discussed all this, so we'll just actually begin. Trigonometry, you have the book now, right? SL Loney.
Oh, yes, sir.
Okay. So SL Loney is the textbook that we'll be following for trigonometry. It's the best book for that. And we will do it comprehensively, like as much as possible. Okay. Again, for coordinate also, we'll be following SL Loney.
Yes, sir.
For other topics, I've already told you which books, right? You have got the Cengage for this and this, right? Algebra and calculus, right?
Yes, I have it.
Okay. So right now we will start with the SL book. Trigonometry basics you already know, right? Trigonometry was introduced in 10th grade and you know a little bit of it, right?
Yes, I know.
Basics from 10th grade was what? There were some 6 ratios that were defined, right?
Yeah, the basic 6 ratios.
So the basic 6 ratios were defined with respect to angles in a right angle triangle, right? So if there is
Yes.
a right angle triangle A, B, C, and this is 90 degree, then for this angle theta or for this angle alpha, whatever, right? For both of these angles, we can define ratios. And what they defined was, they defined 6 ratios, which were like sine theta, cos theta, tan theta, and reciprocals of these, right? Which is
Cosec, sec, cot.
cosecant theta, sec theta, and cot theta. So these ratios were defined for, say, this angle. Similarly, you could have written all the 6 ratios for alpha also, right?
Yes, sir.
You could have written sine alpha, cos alpha, and so on, right? So what was the meaning of each of these ratios? Why am I calling it ratios, first of all, right?
This is the ratio of the sides of the triangle.
Correct. So this is the ratio of the side lengths, right? So it will have some numerical value, right? Sine
Yes,
theta
sir.
will be some numerical value. So, okay, so sine theta will be perpendicular by hypotenuse. So it will be
AB by
AB
AC.
by AC, and cos will be base by hypotenuse. So BC by AC, and tan will be perpendicular by base. So AB by
B by BC.
BC, right? So great. So this we defined, and then we quickly saw Pythagoras theorem. Pythagoras theorem says that AB square plus BC square is equal to CA square for the triangle, right? And correct, no? So
Yes,
if I
sir.
divide by CA square on both sides, what will happen? AB square by CA square plus BC square by CA square is equal to 1, right?
1.
Which implies that AB by CA is which ratio? Is sine, right?
Yes, sir.
Sine square theta, and BC by CA
Cos
is
square
cos
theta
square
equals to
theta.
1.
So you get the identity sine square plus cos square is equal to 1, right? And here
Yes, sir.
you should also notice that tan is equal to sine theta by cos theta, right?
Yes, sir.
Tan theta is sine theta by cos theta, because if you do AB by AC divided by BC by AC, you get AB by BC, right?
Yes, sir.
Similarly, now using this identity, divide both sides by cos square theta, it will become tan square theta plus 1 is equal to secant square theta, right?
Yes, sir.
And divide by sine square theta, you'll get 1 plus cot square theta is equal to cosecant square theta, right?
Yes, sir.
So that's all trigonometry that you learned in 10th grade, okay? So actually it was worth like 5-10 minutes only. That much only what you learned, right?
Yes, sir.
What we will be doing, however, is understanding that these trigonometric ratios don't just have or you don't just understand them in terms of angles of a right angle triangle. You have met them for the first time in a right angle triangle. That doesn't mean that's all that they can do, okay? So what we are going to study now is the subject of trigonometry where the angles can be any angle,
Yes, sir.
okay? So the input to this, the sine, the theta to this could be any theta. It doesn't have to be just in a right angle triangle, okay? So when that happens, when it is not just restricted to be any particular angle in a right angle triangle and can be any angle whatsoever, the values also can be in a range, right? Values also could be in a different range. So for example, for the right angle triangle, you had learned the table of values, right?
Yes, sir.
And in that table, you saw that all values were 0 to 1 something, right? Except for
Yes, sir.
tan, obviously. Sine and cos values were 0 to 1. Tan values were above 1 also. Infinite also was possible, right?
Yes, sir.
So when theta was 0, this was 0, this was 1, this was 0. And 30, it was half, this was root 3 by 2, this was 1 by root 3, right? And so on,
Yes.
correct? And so on, you're constructing values, but you saw that sine and cos were between 0 and 1, right?
Yes, sir.
Now, when you don't have the restriction on the values of theta, and theta can be larger than 180 also possible, right?
Yes,
Right.
sir.
Then what we will see is the values also will have a bigger range. So it will not just be always positive. It could also be negative. Okay.
Yes,
So
sir.
we will try to understand all of that. So let's see. So the first thing that you need to figure out in trigonometry is angles in general are written using a new unit, called radians, new unit called radians. You don't talk of angles in terms of degrees anymore.
Yes,
Okay.
sir.
So what is this radian unit? So let's see. So there is a unit circle, let's say. Okay. Unit circle, by unit circle, I mean circle of radius 1. Unit circle, circle of radius 1. Okay. So let's say we have a circle like that, and center of the circle is the origin. Okay. So this is x-axis, this is origin, this is y-axis, right?
Yes, sir.
And we have drawn a circle, and a point can move along the circle however you want. Like there is a point P that keeps moving along the circle circumference, right?
Yes, sir.
So now what we want to understand here is that this circle's radius is 1, right? So this angle, right? This angle, theta, can
Yes,
be written in a way that captures that fact. So how? So see, you know that this arc length from this point to this point, right? Arc
yes,
length will be what? Arc length should be r into theta.
yes, sir.
One way to explain it is this: like, what is the total circumference? Total
2
circumference of
pi
the
r.
circle is what? 2 pi r, right?
Yes,
So in this case, radius is r is 1, right? So 2 pi, right?
yes, sir.
Total circumference is 2 pi, right? And total, if you go the whole angle, right, and come back to the same point, right?
Yes,
Correct.
sir.
How much angle do you cover?
360.
360 degrees, right?
Yes, sir.
So 360 degrees corresponds to how much length that you cover. If how much length does this point P cross if he goes the whole distance like this till here?
2 pi.
2 pi, right?
Yes,
So
sir.
360 degree corresponds to 2 pi length, right?
Yes, sir.
Correct. So 1 degree should correspond to how much length? 2 pi by 360
360.
degrees, right? 360, right?
Yes, sir.
I'm removing the unit degrees because 1 degree here, right?
Yes, sir.
Just divide by 360 a number, right? So this is pi by 180, right?
Yes, sir.
So what we get, this distance we can call radian, and we say
Pi
that pi
radians is
radian
180 degree.
is equal to 180 degrees, right? So in this context, that when you walk along the arc, right, the length of the arc described can be written in terms of the radian thing, right?
Yes, sir.
And 2 pi was the total and 360 degree was the total, right? So pi radian will be 180 degrees. So now from now onwards, many times you will see that they will write angles like pi by 3, pi by 6, pi by 2, pi. What it really means is 60 degrees, 30 degrees, 90
Yes, sir.
degrees, 180 degrees, 2 pi is 360 degrees. When you write radian, you don't put a degree or anything, okay? You
Yes, sir.
don't even say radian. Radian is a dimensionless thing. So you just say pi by 3. Okay, pi, it's actually just a plain number, pi by 3.
Yes, sir.
Pi by 3, pi by 6, pi by 2. And pi is our regular pi, 3.14159 and all, right?
Yes, sir.
Correct. So we will be using this new unit called radians, and in that sense only we'll be talking about things. Now what I want to understand is uh, how do you describe the trigonometric ratios when you come to angles which are not just part of a right angle triangle, right? Correct.
Yes, sir.
So again we'll go back to our unit circle. Again we'll go back to our unit circle and we'll draw our x-axis, y-axis. This is y, this is x, and this point is moving like this, right?
Yes, sir.
Point is moving like this P. So from a P point, right, if I want to draw the ratio, right, if I want to find the ratio, I want to describe this angle. So angles are always measured with the positive x-axis. This is my theta, okay, for the P
Yes.
point. So angles are always measured with the positive x-axis. So what does that mean? Like basically to specify any angle, you need two lines, right?
Yes, sir.
Two lines will make an angle, no?
Yes, sir.
So just keep in mind that one of those lines will always be the positive direction of the x-axis. So OX line, okay? OX line is one of the lines, and OP line, which is how the particle is moving, right? That will be your other line, right?
Yes,
So
sir.
OP line will be describing bigger and bigger angles as you move in a anti-clockwise manner, right? Correct.
Yes, sir.
If you come in the second quadrant, for example, right? This is my angle, theta.
Yes, sir.
If you come in third quadrant, for example, it becomes even bigger. It
Yes,
becomes,
sir.
this is my angle theta, right? For P, right?
Yes, sir.
If you come here, it becomes even bigger, right? Eventually, it will become close to 360, and finally, it will come back to here, which
0.
is 360 or 0, you can say, right?
Yes.
So, so that is the understanding that positive angles, these are called positive angles. So this side, when you keep measuring angles, right, you will keep saying this angle is plus 30, this is plus 60, this is plus 9, plus 90 would be here vertical, plus 180 will be here, right?
Yes, sir.
Correct. But you could also have gone in a clockwise manner, right? It's not like P has to always move anti-clockwise, right?
Yes, sir.
So in case someone was moving in a clockwise way, then these angles, suppose he went from here to here, right? Here.
Yes.
Then if you measure an angle in a clockwise way, you will call this angle as minus 30 instead of 30.
Yes, sir.
So there is a sign associated with the angles. Okay. So if I move in an anti-clockwise way, anti-clockwise manner, I call that a plus angle. Okay.
Yes,
And
sir.
if I move in a clockwise manner from the
Negative.
x-axis, it will be negative angle. So basically, I can say that if I am on a circle, if I am at a particular point here, right?
Yes, sir.
This angle, let's say, is on, if I moved like this angle can be written as plus 210 degree, let's say, right? That
Yes, sir.
means 180 till here and 30 in this part, right?
Yes, sir.
But it can also be written as
Minus 150.
minus 150, because 90 till here and 60 in this part, right?
Yes, sir.
So the same minus 150 is same as plus 210. That is what you have to understand.
Yes,
Okay.
sir.
So plus 270 is the same as minus 90, right?
Yes, sir.
Correct. Notice that the difference between these two is 360, right? The
Yes, sir.
difference between these two has to be 360. Once
Yes.
you have a difference of 360 between two angles, that means basically you have ended up at the same point, right?
Yes, sir.
Right. Okay. So that is first thing to understand. Now what we will do is how to write the ratios, how to write all the ratios. See, suddenly now our angles have expanded to minus 360 to 360, right?
Yes, sir.
Or basically we can say minus 2 pi to 2 pi radians, right?
Yes, sir.
When you were talking in 10th grade of just about right angle triangles, your angles could maximum be 0 to 90, right? Like
Yes, sir.
it couldn't even be above 90, right? Because in a right angle triangle, you cannot have this angle 90 plus, right?
Yes, sir.
It had to be between 0 to 90 degree, right? Correct.
Yes, sir.
So that was the limited range in which you were learning trigonometry earlier. And this is the full thing. Okay.
Sir, but we can go more than 360, right? And like
But
more
that
than,
doesn't matter, no, actually.
I
Because
mean, like it's a rotation, like you come back to the same point.
so basically what happens is any angle above 360, you can remove 360 from it, right?
Yes, sir.
It is the same thing, no? 360 degree is actually coming back to the same point. So you can go around the circle 10 times and you have covered 3600 degrees, but you can also call that 0 degrees.
Yes, sir.
So basically, if you know this much, then that is enough, right?
Yes, sir.
Any other angle you don't need to care about, right? Makes sense.
Yes, that makes sense.
So basically now we are expanding our understanding of sine, cosine, tan and all from 0 to 90 to minus 2 pi to 2 pi. Okay. That is
Yes,
what
sir.
we are doing. Okay. So then let's try to understand how to write the ratios. Just hold on for a second. I'm getting some messages. 1 second. Hello.
Hello. Yes,
Yeah.
sir.
Uh, so what we will see now is this circle, and suppose this person is P point is here, this O is here, okay, and this is my x-axis and this is my y-axis, right? Now I want to understand first if my P is in the first quadrant, okay.
Yes, sir.
If my P is in the first quadrant, how to define the ratios, how to define the ratios, right? So
Yes, sir.
what you have to do is follow these steps. Drop a perpendicular from P to x-axis, okay. Drop a perpendicular from P to x-axis. I have dropped this perpendicular, right? So let's say
Yes,
this
sir.
is Q, okay, and join P to center O, right?
Yes, sir.
So join P to center O, okay. So now for this angle, since the point was moving like this, the angle was the angle theta here only, this angle only, no?
Yes, sir.
So all the ratios for the theta can be defined simply in right angle triangle OPQ.
Yes, sir.
Okay. So basically just do your regular stuff. This I have just constructed a right angle triangle, right?
Yes, sir.
So all the sine theta, sine cos theta and all will be defined with respect to this right angle triangle.
Yes, sir.
Okay. So you know how to do that. Sine theta will be PQ by OP. Cos theta will be OQ by OP and tan theta will be PQ by OQ, right?
Yes, sir.
Great. So any angle till here, any point till here, you can capture like this, right? Because you will keep dropping perpendiculars and making right angle triangles, right?
Yes, sir.
Fine.
So all the angles in the first quadrant are positive, right? All the ratios.
All the ratios in first quadrant are positive because that thing I did not mention. So your ratios will be what? Your ratios will always be perpendicular length by distance OP, right? Sine will be this always, right?
Yes, sir.
Cos will be base length, right? Cos theta will be base length by distance OP. Notice that uh, by convention, by definition, even if you go to the other quadrant, right, the only thing that is positive here will remain positive throughout is distance OP, which is
Yes.
the radius of the circle, okay. If you go to this quadrant, right, your point is here and then you'll drop a perpendicular like this, right?
Yes, sir.
Okay. And again, your sine theta is now this big angle, okay.
Yes, sir.
Theta is now this big angle. It will still be perpendicular by hypotenuse, perpendicular by distance, okay.
Yes, sir.
And base will be this base by distance, okay. But in this case, base becomes negative x, right?
Yes, sir.
Right, because this is plus x and this is minus x, this is plus y and this is minus y, okay. The only thing that has no negative connotation is the radius of the circle, which is the
Yes,
distance
sir.
OP. So anytime distance OP appears in my trigonometric ratio, that will always remain positive, okay. So
Yes, sir.
I will, so first quadrant is fairly straightforward. I will just go to the second quadrant stuff. So second quadrant, for example, so suppose you have a situation like this. This is your O. If you are in second quadrant P here, right? The angle for which you want to define your trigonometric ratios are these, okay? Okay.
Yes, sir.
This is the angle, no? Because you started measuring angle from the x-axis, right? So I want something like sine theta, cos theta, and tan theta, right?
Yes.
That is what I want to find out. Now, the definition is that construct it in a similar way. Do this, drop a perpendicular to the x-axis, right? And
Yes, sir.
say that sine theta will be equal to length of the perpendicular, so PQ by radius of the circle, okay. Cos theta will be equal to, in this right angle triangle, base, which is OQ by OP. Tan theta will be equal to PQ by OQ, right?
Yes, sir.
So now if you see here, what happens is PQ is still positive, right? It is still in the plus Y direction, right?
Yes, sir.
This is positive, but this is negative, right? So this ratio becomes negative and this ratio becomes negative, right?
Yes, sir.
So sine remains positive,
Positive.
however, right?
Yes.
So second quadrant, when the angles theta is between 90 to 180, right?
Yes, sir.
Sine is positive, cos and tan are negative, right?
Yes, sir.
Cos and tan are negative. In first quadrant, all are positive, right?
Yes, sir.
All positive. This one is sine positive,
So
right?
cosec will also be positive.
Obviously, those things I'm not saying because that is obvious, right? Reciprocal
Yes.
will be. Let's worry only about the top first three because the others are reciprocal, right?
Yes.
Correct. So if I go to the third quadrant now, right? Now think about it. The third quadrant angles are actually really big, right? Third quadrant angles would be, some point will be somewhere here. So angle would be actually this angle, right?
Yes, sir.
So it is actually angles are above 180-degree, and that time we want the ratio of sine, cos, tan for such big angles, right?
Yes, sir.
Again, do the same thing. Drop a perpendicular here like this. Okay. Drop a perpendicular and then take the same ratio. Length of perpendicular by radius will be sine. Okay. So sine theta would be, in this case, you see that perpendicular is now in the negative direction.
Yes, sir.
So sine theta will be negative. Radius is always positive. Okay. Correct.
Yes, sir.
Cos theta. Think of cos theta. Cos theta base by hypotenuse. So base is also negative and radius is positive, right? So cos is also negative.
Yes, sir.
Makes sense.
Yes, sir. Tan is positive.
And tan is positive. So in the third quadrant, tan is positive, right?
Yes, sir.
Sine and cos are negative here. Okay. So if someone asks you sine of 210-degree, it has to be negative.
Yes, sir.
Someone asks you cos of 150-degree, that also has to be negative because in second quadrant, cos was negative, right?
Yes, sir.
Okay, great. So this is done. And fourth quadrant, if you come to now, see, again, I will define the angle till here, but my real triangle will be here, right? Perpendicular, right? This
Yes,
is
sir.
my perpendicular. Now, since perpendicular is negative and radius is positive, so sine is negative. Think about the cos. The base is, look at the base. Base has become positive now, right?
Yes, sir.
And
So cos is
hypotenuse is
positive.
positive. So cos is positive and tan will be therefore negative because one of them is negative, one of them is positive, right? Correct.
Yes, sir.
So this is the situation in fourth quadrant, and in fourth quadrant cos is positive. So you get this nice rule that all sine, tan, cos. So you should remember this four quadrants. Which ones are positive basically, right?
Yes, sir.
So you can remember it like, generally there are mnemonics for this. ASTC. You can say add sugar to coffee, right? So that is just
Yes.
to remember for the first time and all, right? But otherwise, in general, it is easy to figure out also. If you forgot, easy to figure out which one will be. If you know the rule of how to generate the trigonometric ratios, right?
Yes, sir.
The rule is drop a perpendicular, take perpendicular by hypotenuse, base by hypotenuse, and perpendicular by base in the right angle triangle that comes, right? And
Yes, sir.
remember that hypotenuse is the only distance that is always positive because that is the radius of the circle, right?
Yes, sir.
Okay, great. So now what I want to do is expand the, so first I will write a table. First I will write a table of values. So let's say this is 0-degree, 30-degree, 60-degree, 90-degree. This is sine, cos, and tan, right? Okay. And my values here are 0, 1, 0. This is half. This is root 3 by 2. This is 1 by root 3. This is root 3 by 2. This is half. And this is root 3. And this is 1,
1,
0.
0,
And this is infinite or
undefined.
undefined. Infinite actually, right? Very high. Undefined.
Yes, sir.
Okay. So this was my table of values that we knew till 10th grade, right?
Yes, sir.
Now, since now we are able to define angles which are larger and all, what I want to understand is what is the value of, say, sine 120 degree, okay, or cos 210 degree, or tan 330 degree, right?
Yes, sir.
I want to figure out my values here, and there is a way to figure out the values by using just these values, okay? So that is what I want you to learn, where you will be able to predict what the value of 120 degree will be and what the value of this will be, okay, as long as you remember these values, okay.
Yes, sir.
So what we will do is we'll try to understand this. So the method is this. First decide what is the overall sign of the thing going to be, right? Can you decide right away, right now, by the discussion that we have had so far? You can already decide what the sign of this will be, right?
Yes, sir. Positive.
Sine 120 should be positive because it is second quadrant angle, right?
Yes, sir.
And what about cos 210? That is in which quadrant? 210 is in third
Third one.
quadrant, right?
Yes, sir.
In that third quadrant, only
It's
tan is
negative.
positive, right? So this is negative. And tan 330 is in fourth quadrant, right?
Negative.
So negative, right? So already one thing we know at least, that it is positive, positive, negative, negative, right?
Yes, sir.
Correct. The next thing to do is to split the angles. Whatever big angle you get, right? Write it in terms of some multiple of 90 degree plus some small angle plus some acute angle. Okay. So I'll give you example. So 120 can be written as 90
90
degree
plus
into
30.
1 plus some acute angle, right? 30. 210 can be written as 2 into 90 degree plus 30.
Yes,
And
sir.
330 can be written as 3 into 90
Plus
plus
60.
60. So basically, what are we doing? You are understanding the pattern.
Yes, sir.
Any such angle, therefore, can be written like this. No, you can just take away some multiples of 90 and add the acute part, right? The
Yes, sir.
part which is between 0 to 30, right? Great. So once you have split it like this is the rule. Okay. So if it is a even multiple of 90, right? Correct.
Yes, sir.
Sine will remain sine, cos will remain cos, and tan will remain tan. And you just write the acute angle part. Just write it as tan of that acute angle or cos of that acute angle. Okay.
Yes, sir.
Sine, tan, cos of that acute angle. So if it is an even multiple of 90 when you split it like this, right? Which is an even multiple? This is not an even multiple of 90, right?
No, sir.
So if it is an odd multiple of 90, that is the other option.
Yes.
Odd multiple of 90. In that case, there will be a transformation. Sine will become cos, cos will become tan, cos will become sine, and tan will become cot. Okay. And
Yes,
then
sir.
just write the acute part. But first step was what? Decide the sign. Decide the sign. Okay.
Yes, sir.
This is to decide the magnitude. This is called deciding the magnitude. Okay.
Yes.
You have to say both the things, no? So
Yes, sir.
let's apply both the rules. So I know that first we have decided the sign has to be plus only, right? Here. Correct?
Yes, sir.
Because sine 120 should come out as plus, right?
Yeah.
Now we are going to find the value of it. Now see, is it an odd multiple of 90? Yes.
So
Correct.
it becomes cos.
So it becomes cos of that acute part, right? So
Yeah.
plus cos 30. Okay.
Yes, sir.
And this is an even multiple of 90, right?
Yes,
So
sir.
it doesn't change. Okay. So it remains minus, sign has been minus, right? Here, minus cos 30, right?
Yes, sir.
And what will this become? This will become minus, this is changing, no, this is odd multiple of 90, right?
Yes, sir.
So this should become minus cot 60, right?
Yeah.
So now cos
Yes, sir.
30 we already know, right? It is root 3 by 2. So this will be root 3 by 2. This will be minus root 3 by 2, right? And this will be minus 1 by root 3. Because tan 60 I know is root 3, right?
Yes, sir.
So cot 60 is 1 by root 3, right? Correct.
Yes, sir.
So what is the rule? Be very clear about it. First, on the first glance only, by looking at the angle and knowing the quadrants by ASTC rule, you can decide whether it is going, the answer will be positive or negative, right?
Yes, sir.
That you have already fixed. Now we are concerned with the actual value of it, right? So to do the actual value, split the angle in terms of some multiples of 90 and whatever acute portion comes, right? Correct.
Yes, sir.
If it is an even multiple of 90, ratio remains the same and you write just the acute portion, right?
Yes, sir.
If it's an odd multiple of 90, the transformation happens, sine becomes cos, cos becomes sine, tan becomes cot. Notice that this transformation is not totally unusual for you because you know this thing, na? Sine 90 minus theta is cos theta from 10th
Yes,
grade,
sir.
right? So
Yes, sir.
sometimes, see here it was an acute angle, right?
Yes, sir.
Correct. So it was changing, right? Acute multiple, odd multiple of 90 it was, right?
Yes, sir.
So that transformation happens. So I want you to just practice this a bit. I will give you some 7 8 ratios and you find out the values. Okay. So sine 240 degrees, tan 330 degrees, cot 150 degree, secant 300 degree, tan 210 degree, cos cos 9 no cos 150 degrees, cos 150 degrees, and then sine of 330 degrees. Okay, these 7 values, right? Just find out, check, apply the rules that you have just learned, find out the answers. I have a call, I think I'll be back in 5 minutes, right?
Yes, sir.
Just try these till then, right? I will just be back. Okay. Yeah. Have you figured out this one?
Oh yes, sir. Minus root 3 by 2.
So first of all, we decide the sign. It should be negative, right? And then it should be 2 into 190, 180 plus 60, right? So
Yes, sir.
sine will remain sine. So it is sine 60, right? So that will
Yes,
be
sir.
minus root 3 by 2, correct? Then this one,
Minus 1 by root 3.
minus 3 times 270 plus 60. So it is minus cot 60, right?
Yes, sir.
So it is going to be minus 1 by root 3, correct? Hmm.
Minus root 3.
So minus, this is tan 60, right? So
Yes, sir.
minus root 3. Yeah. This one, this is which quadrant? Fourth quadrant, right?
Yes, sir. Root 3 by 2.
Fourth quadrant, and this is sec. So sec will be positive, right?
Yes, sir.
Plus, and it is 270 plus 30. So no, 270. One second. Sec will be positive, and this is 1 by cos, right? So basically, this is 1 by cos 300, right? So that will be 1 by plus cos 270. So it becomes sine 30, right? So it will be 2, no? Just check once. Uh, just hold on for a second.
So what is sec change to?
So yeah, so this one, you understand what has happened.
So what is sec change to?
Don't worry about what sec changes to. Sec changes to cosec, right? But don't do it like that. Convert to cos, right?
Okay, so I
Whenever,
was doing like directly. So
so
sec 90 into 3 plus 30. So plus cos 30. Cosec 30.
so plus cosec 30 will be 1 by sine 30.
Yes, sir.
So don't do
So
sec to
2.
cosec. Do it like 1 by cos 300. No, that is a little longer but easier to think.
So if I'm fine with it, can I do it this way? Because
I mean, you can do whatever, but just don't make mistakes, right?
yes, sir.
The point is do not make mistakes. I'm telling you this to not make mistakes. So sec is 1 by cos 300 and denominator cos 300 is plus sine 30, right? So that becomes plus half in the denominator. So it becomes 2.
Yes, sir.
This one,
1 by root 3.
so it is tan 30, right? Plus
Yes,
tan
sir.
30. So 1 by root 3. And this one becomes negative.
Minus root 3 by 2.
This is 90 plus 60. So minus sine 60. So minus root 3 by 2. Correct. And this becomes negative
Minus half.
cos 60. So half, right? So this is the rule. So you're able to apply it. So that's fine. Now, what I want you to do is open the textbook once. Page number 20. SL Loney, page 20. Exercise 5. Okay. Can you see exercise 5?
Yes, sir. Examples 5.
Yeah. So examples 5 has some questions.
Yes,
So
sir.
what these are questions that you probably have done similar questions in your 10th grade identities. These are trigonometric identities.
Yes, sir.
So you can probably prove many of them. This exercise is homework. Okay.
So the
Uh,
whole?
Yeah. The whole only.
Yes, sir.
So there will be a lot of homework, but I mean, you have to attempt it as much as you can. There's 1 week time also, right?
Yes, sir.
So there will be a lot of homework. So don't worry about that. Uh, for example, some questions here. Let's see one or two questions before we move on. So if you look at question number 4, for example, right? Question
Yes.
number 4 is prove the following statements. Prove that cos 6a plus sine 6a is equal to 1 minus 3 sine square a cos square a. Okay. You have to prove this statement, right?
Yes, sir.
Now you will be using your standard identities that you learned in 10th grade to prove all of this. Okay. So what identity comes to mind here? Which identity might be used?
Sine square theta plus cos square theta
Hmm.
is
So
1.
sine square a plus cos square a is equal to 1 is known, right?
Yes,
So
sir.
from there, I have to get somehow this, right? So the obvious thing to do is cube this, right?
Cube and here.
Cubing this will become
Sine
a
power
cube
6a.
6a plus cos power
Yes.
6a plus 3xy x plus
A
y, right?
square b and ab square.
So 3 sine square a cos square a sine square a plus cos square a, right?
Yes, sir.
This is 3xy x plus y, but this is
Yes, sir.
1, right?
Yes, sir.
So immediately you get the answer, right? This plus this is equal to 1 on the RHS, right?
Yes, sir.
So you have proved this, right? It's one step. Correct.
Yes, sir.
So there will be easy questions like this. Sometimes it might not be so easy. For example, 17th one, if you look at question 17. Sec power 4a minus sec square a is equal to, he's saying prove that it is equal to tan power 4a plus tan square a. Okay. Okay. So actually this is also fairly easy. So work from one side, let's see. So if I do this, I can take sec square a common, right?
Yes, sir.
And this will become what? Sec
Sec
square a
square a
minus 1.
minus 1.
And that is an identity.
Yes, sir.
So that is equal to tan square a, right?
Yes, sir.
And sec square a can be written as 1 plus tan square a.
Yes, sir.
So it is proved, right?
Tan square
Multiplication
a
gives
plus
this,
tan power 4. Yes, sir.
right? So fairly straightforward exercise. Okay. So exercise 5 is homework. So you should mark it.
Yes.
Do questions only till question number, I mean, not only, just skip the last question till
Yes,
question
I was just
34.
gonna ask that.
Skip the last question. Versine is a concept which is an old concept. It's not useful anymore. Ignore that. Okay. So till question 34 in this exercise.
Yes, sir.
Then
So should I
exercise.
like, will we not learn that at all, or
Will not?
learn that at all, or just for
No,
not?
we'll not be learning that. That is not useful.
Yes.
So then exercise 6, right, is on page 25. Okay. Page 25, exercise 6. This is also very simple. Ignore any instances where they're asking versine and all. Okay.
Yes, sir.
So for example, question number 6 is asking tan theta. He's also asking versine theta. Ignore that. In this exercise, question number 6 to question number 22 is doable, like very obvious stuff. Okay.
Yes.
So if you are given one ratio, you can find the other ratios, right?
Yes, sir.
So this is just practice of that, right? Also, whenever we are doing exercises in SL Loney, sometimes you don't have to do each and every question. Okay. Like not in the case of identities. In the case of identities, you might not know how to prove everyone, but
Yes, sir.
especially this exercise, right? This exercise, once you get the hang of it, you don't have to do every question. Okay.
Yes, sir.
Like don't repetitively do the same thing. The point is not to do brute force work, right? The point is to know every type of problem, right?
Yes, sir. So like 6, 7, 8 are like similar. So should I do only one of them, or?
So do whatever, as long as you know what to do, right? So
Yes.
as long as you know what to do one or two of them. 11, 12, 13, you can do one of them, right?
Yes,
11,
sir.
whichever looks difficult, you should do.
Yes,
So
sir.
for example, question number 14, 14, 15 onwards, I think these are fairly interesting. So you should not skip these.
Yes,
So
sir.
if you see 14 is 2 sine theta is equal to 2 minus cos theta, right?
Yes, sir.
And you are asked to find sine theta, right?
Yes, sir.
So now tell me, what will you do here? This is an equation and you are given 2 sine theta is 2 minus cos theta. Think what to do here. Any ideas?
Sir, 1 second.
Hmm.
So can we convert like cos to sine?
How?
So um, so you take 2 to the other side, I think.
Mhm.
So it becomes 1 second. Cos theta equals to 2 minus 2 sine theta.
Cos theta, we take 2 to the other side. So you are saying cos theta is equal to 2 minus 2 sine theta. Then
Yes, sir. And then if you square both sides,
hmm, cos square
uh,
theta is equal to
4
4
plus 4 sine square theta
this,
minus
right?
4 into 2, 8 sine theta.
4 plus 4 sine square theta minus 8 sine theta, correct. Then
So then cos square theta is 1 minus sine square theta.
1 minus sine
Is
square theta. So now it is becoming a quadratic in sine theta,
yes, sir.
right? So you will get 5 sine square theta minus 8
Minus
sine
8
theta
sine theta plus 3, I think.
is equal to 0,
Yes, sir.
right? So 5 sine square theta minus middle term factor, right?
Yes, sir.
This is correct.
So it's just factorization.
So just solve it like this: 5 sine theta common, sine theta minus 1 minus 3 sine theta minus 1, right?
Sine theta minus 1 into 5 sine theta minus 3.
Minus 1 into 5 sine theta minus 3 is equal to 0. And you get two answers. Sine theta could be 1.
Sine theta is 1 or 3 by 5.
Right. Right. So sine theta is 1, then cos theta will be 0, right?
Yes, sir.
It will fit the equation. Okay. So
Yes.
this is the way to do 14th one. If you look at, for example,
So, but what if you don't get the like the whatever the logic immediately, like what to square or what not? Should I like
then try again. I mean, immediately you don't need to get everything.
immediately meaning like for like 5-10 minutes if you don't get it?
Then try it next day.
Okay, yes, sir.
I mean, ultimately you have to get the logic and solve it, right?
Yes, sir.
So the point is that problems when you solve for JE and all, it will not be easy. Problem solving will not be easy. And if you give up very quickly, then you will not learn much. Anyway,
Yes,
I
sir.
will solve it later. Okay. So it's not like the problem will be unsolved forever, right?
Yes, sir.
It's just that enough
Basically, you shouldn't check
attempts.
like the solutions or anything.
Yeah. If you check solutions and all, it's not useful for you. It's
Yes, sir.
just you'll forget it in 3 weeks or 2 weeks.
Yes, sir.
Again, this problem will come up somewhere else and you'll again be stumped. So the idea is to spend as much time as possible. If you're stuck on it, you cannot figure out anything, then move on. But later come back to it once more, mark it in the book, right? Mark
Yes,
it
sir.
that this is a problem that I need to come back and revisit, right?
Yes. So by the end, if I don't get anything, can I come and ask you?
Obviously, we'll be discussing them in the class. No?
Okay, yes, sir.
All the problems will be discussed later in class, but spend enough time. It is not useful if you just look at it, oh, this is difficult, let me just ask sir in the next class, right?
Yes.
That is not going to be useful. So that will just ruin your learning process. So don't do that, but otherwise try yourself as much as you can. Later we'll solve them eventually, right?
Yes.
So for example, 16th one, tan theta plus sec theta is equal to 1.5, and you have to find sine theta. Okay.
Yes, sir.
Now this one, you could also do something similar to what you have done many times in these questions. It is going to work out if you convert everything to the sine
Sine and
and
cos.
cos, right? So sine by cos plus 1 by cos is equal to 1.5, right?
Yes.
And you can do the same thing you did, took the cos this side, square it, convert it
Yes,
to
sir.
1 ratio, right?
Yes, sir.
But smarter way would be this secant square theta minus tan square theta is equal to 1, right?
Yes, sir.
So this can be factorized as sec theta minus tan theta multiplied by
Sec
sec
theta
theta
plus
plus
tan.
tan theta. And we know the value of sec theta plus tan theta, right?
Yes, sir. 1.5.
So this is 1 and this is 1.5. So this sec theta minus tan theta we suddenly know now. So it is 1 by 3 by 2. So 2 by 3, right?
Yes, sir.
And sec theta plus tan theta also we know, right? Which is
Yes.
3 by 2, right?
Yes, sir.
So
So
if you
2
just
sec
add
theta.
them, so sec theta will be half of 2 by 3 plus 3 by 2, right?
Yes. Sir.
So suddenly you got a ratio, right? Once you got a ratio, you'll be able to find sine, right?
Yes. Sir.
So this method also keep in mind, you are using the identity intelligently, right?
Yes. Sir.
So example 6 basically attempt till the end, till question 22. Just skip some repetitive ones, right?
Yes. Sir.
Okay. Then the next thing to do is we will move on to chapter number 4. Okay. Chapter 3 is heights and distances. We'll not be doing chapter 3. Okay. And chapter 4 we'll move on to.
So is it there in the portions or not?
No. Heights and distances is basic stuff. It will not be asked. So
Yes.
we'll go on to chapter 4. Okay. And chapter 4 is called Application of Algebraic Science to Trigonometry.
Also, sir, should I study the theory from the book or is that not required?
No, anyway, I'll be teaching you all of that. So don't worry about it. So,
Okay. Yes.
I mean, I'll be teaching you all of this. So anyway, you don't need to read it right now. When I'll tell you to read it, you read it, right?
Okay. Yes, sir.
So there will be a point where you'll have to read it, like chapter 15, you have to read, but right now you don't need to. So actually skip chapter 4 also, go to chapter 5, okay? Because I have already told you everything about chapter 4 in this class. Okay. If you go to chapter 5, page number 58, okay? Page number 58.
So what about the graphs, sine graph and cosine
I will
graph?
teach you that, but right now it's not necessary. That's why I'm not told you.
Yes, sir.
So look at page 58, exercise 10. Exercise 10,
Yes.
page 58. This is chapter 5. Okay. So that exercise is now completely doable for you.
Yes, sir.
Okay. Because look at all of these values you can find out. See,
Yes.
sometimes they are giving very big values, right?
Yes, sir.
So how to handle those big values like 843 degrees and all? How
So
would
can
you
we
do it? Like for
can we
example,
just subtract 720?
exactly. So sine for 843 will be simply take two rotations of 360 and take them out, right? That doesn't
Yes.
count.
So sine 123.
So sine 123, right? So sine 123 now, you have to write it in terms of, he's saying, write it in terms of ratios of a positive angle, which is less than 45, right? So this is
Yes.
90 plus 33, no?
Yes, sir.
90 plus 33. So this will be cos 33, right?
Yes, sir.
So that is the answer. Okay. Makes sense, right?
Yes, that makes sense.
So try this exercise, example 10, right? This will also be part of your homework. Okay. So the idea is basically the first exercise 5, exercise 6, and exercise 10. Okay. Exercise 5, exercise 6 and exercise 10. That is the homework for this class. That is
Yes.
all the stuff that we have discussed so far. Okay. So you get the sense of what to do, right?
Yes, sir.
We will be doing in the next class, we'll be looking at the graphs of trigonometric functions, and we'll go on to chapter 6 and chapter 7. Okay. Chapter 6, 7, we'll be going on to that. So
Yes.
basically, we will be progressing very fast in this book. Uh, Ultimately, the goal is to finish till chapter 15. Okay. Our target is to go till chapter 15. So the chapters that we will be doing are basically 6, 7, 8, 9, 6, 7, 8, 9, 12, and 15. These are the chapters that we have to cover.
Yes, sir.
Chapter 6, 7, 8, 9, 12, 15. So our job is to do this as comprehensively and as fast as possible. Like, it's important to do it really well so that you know everything in this, but it is also important to do it fast.
Yes.
Okay? Because there is a lot of stuff to learn, right? So it's not like we have to keep doing this forever, right? So I want you to finish the homework, be very diligent with that, make sure that you know everything that is covered here, or if you have doubts, ask me and solve it in the next class, right?
Yes, sir.
All the doubts that you get, we will solve in the next class, and we'll go on to chapter 6. Okay.
Yes, sir.
I plan to finish this in 1.5 months or so. Like, so right now is Feb 19, right? So by March something 20 or something, or even March 20, no, it will be March end, right? March 31st, let's say. We should be done with trigonometry. That is the target. Okay. So
Yes, sir.
that we can move on to different units. Because anyway, this is not going to be too difficult, except for the chapter 12 and 15 part, which will be slightly challenging. This is not difficult, trigonometry. Okay. So you have to come with that confidence yourself. Like, you have to have that confidence. Yeah, I can do it.
So
Right.
the chapters we're skipping, like, are they like totally skipped in the portions also, or is it?
Yeah, it's not important.
Okay, yes.
What I'm telling you, whatever we are going to do in class, that is what is important. Okay.
Yes.
So for example, chapter 5 and all we have already done. Like, it took like half an hour to explain, right?
Yes, sir.
We are skipping some chapters like logarithms, principles of proportional parts, heights and distances. Again, those chapters we are skipping right now. So when the time comes, we'll do it. But right now, some of those chapters we don't have to do actually. Some of those things like logarithms and all I will teach you later.
Yes, sir.
But that will come more or less in the algebra parts. Okay. So this is the work for the class. Make sure that you finish this and come. Okay.
Yes, sir.
Tomorrow we'll be doing physics. So HCV you have, right?
Yes, sir.
Okay. So a little bit of calculus also I have to teach you. So we'll need a little bit of calculus for physics. So that will come especially in maths later. It will come. But right now, before the class, I'll have to teach you a little bit, because HCV immediately it will start in physics. Immediately you have to use calculus, right?
Yes.
So we will figure that part out. So tomorrow we'll do physics. That's all for today then. I'll see you same time tomorrow evening. Okay.
Yes, sir. Thank you, sir.
Okay. Bye.
Bye.